Hello everyone, today let's solve the problem, this one, jump game 7, right? So basically problem number 187, right? So let's go with the question. First, we start at the index 0, right? So we start at the index 0, they have given here, we have been given string here, and we start at the index 0, first thing, of the binary string s, right? S of 0 equivalent to 0. From index I we can jump to any j. From index I we can jump to any j, right? So from index I we can jump to index any j, right? With I plus minimum jump, this one, j greater than or equal to I plus min jump, and j less than or equal to I plus max jump, right? Provided s of j equivalent to 0, right? So we have to return true if we can reach index s dot length minus 1, right? So otherwise we have to return false, right? So we have to return only if we can reach the index s dot length minus 1, otherwise we have to return false, right? So we have to find the linear time, this one in linear time, right? So we can just go with the greedy or the sliding window solution. Either of them, or we can just go with a greedy sliding window solution, right? So this is fine. So here we have been given string s, see here, min jump equals 2 and max jump they have given 3. So see here, in the first step, move from index 0 to index 3. See here, from 0 to 1 2 3. From the first step we are moving from index 0 to index 3, right? In the second step we move from index 3 to index 5, right? So from here again 0 to 6 we can just move. It is possible. It is possible. Here in this case we will be returning true. So see here, we have been given this one string, this one, 0 1 1 0 we cannot, right? We cannot, in the sense we cannot reach the index, last index basically, right? So we cannot reach the last index, so in that case we have to return false. So that's what we have done here, right? So they have given us wonderful example just for the sake of understanding here. This is fine. Now as we are completely familiar with the question, let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code, right? So here let's consider the same example, this one, right, for the approach. So first thing here, s we have been given 0 1 1 0, 0 1 1 0 1 0. This is fine. Min jump we have been given 2 and max jump we have been given 3, right? So we keep a boolean dp of I, meaning index I is reachable. This is the first thing that we need to remember. We will be keeping the boolean dp of I, meaning index of I is reachable. See, again I'm telling, we'll be making use of dp. This is fine. So mainly we will be going with a greedy along with a sliding window, right? So we'll be making use of the dp as well, right? These things, just keep this in mind. We will be keeping a boolean dp of I, meaning index I is reachable, right? So what is the greedy idea then here? We will be making use of the greedy approach, right, as I've said. So what is the greedy idea here? So for each I, the previous indices that can reach I, right? So for each I, the previous indices that can reach I lie in the window I minus max jump, comma I minus min jump. So if I am calculating that further, so this is the main idea. If I'm calculating this one by considering the example, so this is the main idea. Just remember this one. For each I, the previous indices that can reach I lie in the window I minus max jump, comma I minus min jump, right? So we will maintain a running count of how many reachable indices are inside that particular window, meaning we'll be going with a sliding window, right? So if count is greater than 0 and s of I is also this one, and s of I is also 0, then what we will do, then we will mark dp of I equals true. Simple, right? If count is greater than 0 and s of I is also 0, then what we will do, we will mark dp of I to true, right? So we will be updating the window incrementally as I increases. As we are going with the sliding window, what we are doing, what we'll be doing basically, we'll be updating the window incrementally as I increases, right? So this is the approach basically, right? This is the approach basically, and this is the greedy idea as well. Right, now let's consider the first example. Let's try to implement the same, right? So now first what we will do, first we will be having dp array. So dp of how many this consists of, for the first example basically 0 triple 1 0 1 0, 6 elements we have, right? So first element will be true and the rest will be false here. So this one will be ff 4 times 5 times, right? T followed by 4, this one here, this is fine. This is the first step. So let's go with the first iteration here. This is I equals 1. When I equals 1, so window will be empty, right? So window will be initially empty. So count will be 0 here. C is nothing but the count will be 0 and S of 1 will be quite obviously 1, right? So S of 1 is quite obviously 1. So initially dp this one will be dp of this one and count will be initially 0. S of 1 is 1, next S of 1 is 1 and dp of 1 is false, right? So dp of 1 is what we have, dp of 1 is nothing but false here. This is fine. Yep. Now let's consider when I equals 2, right? So when I equals 2, so I equals to 2, what we will do, we will add the index 0. We will add index 0, right? So let me go with index 0. We will add index 0, I minus min jump equals 0 and I minus max jump. So that one I have already explained. So I minus min jump will be equivalent to 0 and dp of 0 is equivalent to the t. So count will be 1 here, S of 2 will be 1 and dp of 2 will be false, right? So count is for this one, count will be 1 and S of 2 is 1, this is fine, and dp of 2 is false, right? So dp of 2 is false, right? So this is until I equals 2, for the I equals 2. Next let's go with the I equals 3. I'll just write this one, what do we call, S of the count, this one S of 1 2, next we have to go with S of 3 and dp of 3. So these three things I'll write. So we don't have space here, right? So let me go with I equals 3 here. For I equals 3, so this window includes 0 and index 0 to index 1, right? So count remains 1 itself here. dp of 1 will be false. This one S of 3 will be 0. So S of 2 previously we have considered. Now S of 2 was 1. So this time S of 3 will be basically S of 3 will be 0 and count greater than 0 here, right? So count greater than 0 and also as count greater than 0 and S of 3 is 0, dp of 3 is true. dp of 3 here would lead to true. This is fine. So this is for this one when I is 3. So next let's go with I equals 4, man. This is fine. I equals 4. For I equals 4, what we will be doing, so we will be adding index 2. So the same steps, man. I equals 1, I equals 2, I equals 3. So total we have will go until 5, right? We have until 5, meaning 6 elements we have. The indexing starts from 0. So we have to go, I'm just showing the iteration. Basically I'm dry running the code. Approach I have already explained. So dry running, someone has asked in the comments, so just to dry run the code so that it will be helpful. So I'm dry running as well. So when I equals 4, so what we will be doing, so we will add the index 2, meaning dp of 2 equals false. Then we will remove the index 0, nothing but left of the window, which was t, basically t in the sense true, right? So count becomes 0 here. When count becomes 0, for the I equals 4, S of 4 will be 1, S of 4 will be 1 and dp of 4 will be false, right? So dp of 4 will be false. So this one, let me go with dp of 4 will be false, right? So next finally let's go with I equals 5, the final one, right? So when we have the element 0 here, this one, right? So here we have to add the index 3, meaning dp of 3 equals t, right? So count will be equivalent to 1. So S of 5 becomes quite obviously 0 here, right? S of 5 becomes 0 here. And this step, S of 5 becomes 0 and count will be greater than 0. right? Count has to be greater than count is greater than 0, and dp of 5 we have to set this one to true. dp of 5 we have to set this one to true, right? So dp of 5 we have to set this one to true, right? So this is the last index, and here last index is reachable as we have got true. So what we have to return? We have to return true, right? So I'll just come here, this one here we have got true, which is equivalent to the output they have given for the first example, nothing but the true, right? So last index is reachable, so basically we have got true here, and we will be returning true, right? So the output that we got here is true, which is equivalent to the output that they have given for the example 1 within the question, right? So our approach works absolutely correct in this case, right? So our approach works absolutely correct in this case. So in short terms, what we have done, this is nothing but the greedy approach, because we are just tracking only whether any valid preceding reachable index exists or not, nothing but count greater than 0. I showed in every step, right? Some of the steps basically, and we don't have to explore multiple paths, right? So we are going with dp along with the this one, dp along with the sliding window and greedy, mainly the greedy approach, right? So this is about the this is it for the approach. Next, let's do one thing. Let's quickly discuss the complexities part, man. So what will be the time complexity and the space complexity? So the time complexity would be big O of n. So the time complexity would be big O of n. So why it is big O of n? Here, for each index I, or each index I is processed in constant time, right? So by incrementally updating the sliding count accordingly with the approach that we discussed, right? So overall time complexity would lead to big O of n. So what would be the space complexity here? The space complexity would be big O of n as well, right? So the space complexity would be big O of n as well, because we will be making use of the dp array. As I've said, we'll be going with the dp. We will be making use of the dp array of size n, which is used to store the reachability, right? So dp array of size n, which is used to store the reachability, right? So this can be reduced with more tricks, but whatever the code that we'll be writing will be very simple and clear, right? So basically we are we will be solving the, or we are solving the this one Leetcode questions. At the end of the day, we are solving for the interview preparation, or this one for the preparation purpose itself, right? So the code has to be simple as well as the clear, right? So currently I'm just solving. This is fine, man. Now the time complexity and the space complexity for the code that we'll be writing in the future would be big O of n and big O of n respectively, right? So I hope this part is completely clear, man. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So as discussed on the approach, first thing is we'll be making use of the length of the s, right? So length of the string everywhere. So I'll just assign this one to the variable n. So I'll just go with s dot length here. This is fine. Next, as I've said, we'll be making use of the dp array, right? So dp of I will be true, meaning index I is reachable, right? So this is from the approach we know. So I'll just go with the boolean here, dp equals new, let me go with boolean, so let me pass n here. This is fine, simple. The next step is the starting position is always reachable, right? So let me go with dp of 0 and set this one to boolean value true, and also we need the count accordingly with the approach. So let's go with count equals 0, meaning count 0, because we will be going with the sliding window count of reachable indices in the current window accordingly with the approach, right? So that's what I explained in the approach. So next, what we have to do, we have to iterate over every index I, meaning we have to go with a candidate, right? So become to become reachable. Basically, let's go with the iteration part. So this will be simple for loop, int I equals 1. So this has to be I less than n and I plus plus. So within the for loop, let me go with int add index equals I minus min jump. So this is fine. If add index, if it is greater than or equal to 0, and dp of add index. So yeah, this is it. We are writing this one if condition, right? So this is fine, man. If basically what we are doing here, int add index, this one line number 9. So we are going with the index that newly enters the window for the position, right? So next if condition, whatever I have written with in the line number 10. So if that index exists and if it is reachable, then we have to include it in the window count. So that's what we did in the approach. I showed you step by step the iteration part, right? So let me increment the count here. So this is fine. Now let's do one thing. Let's go with the index that leaves the window when considering I, right? So I can just write here int remove index equals I minus max jump. So let me give here max jump minus 1. So this is fine. The next step is let's go with a simple if condition here, meaning if that leaving index exists and was reachable, then we have to exclude it from the window count, right? So how can we articulate in the form of code? So if let me copy this one, man, I don't want to type. So this one, if remove index, if it is greater than or equal to 0, and dp of again remove index within the array. So meaning here, if that leaving index exists and was reachable, then we have to exclude it or remove it from the window count, meaning we have to decrement the count here. So this one will be count minus minus. So this is fine. Now let me come out of this one entirely. We are left with only some steps here. So if there is at least one reachable index in I minus max jump and I minus min jump, and if s of I equivalent to 0, then I is reachable, and we have to set the dp of I to true in the coding terms, right? So if count is greater than 0 and so let's write that one, man, rather than explaining. So if count, if it is greater than 0 and s dot, so this one char at this one I if it is equivalent to 0, then what I'll do, let me set this one dp of I to true, then I is reachable. This is fine. Otherwise dp of I remains false. This one we don't have to mention that dp of I remains false by default, right? So we don't have to mention this one. I believe. So let's not mention it. If it gives any error, so then we can come here and mention dp of I equals false. That is not required. Basically by default dp of I will be false, right? So this is fine. Finally we have to return the answer, that is last index, right? Is last index reachable or not? That will be the answer, right? So last index, basically dp of n minus 1 we have to return. So I'll just go with return. In our case, whatever the example that I showed you, in this case it was reachable, man. So I can just check it out in the same way for the example 2. It will not be reachable, so you have to return false in that case. So every time I say this, I insist you to try out for the different example that I show within the this one approach. Usually I consider the example 1, most of the times I consider example 1, so that you can just try it out on the different examples in the same way. Don't just blindly follow the same thing, just try it out for the other examples, right? So this is fine. Now what we need to return here, dp of n minus 1, as I've said. So we are done with the coding part. So let me format the code once and let me hit the run button. So we have error here. Oh yeah, this j has to be capital, man. Line number 9. So this j, let me give capital J here. Let me run this one again. Dp of add this one add index I has to be capital. Line number 10. Again, let me run this one. So this is fine. Yeah, sample test cases are getting passed. So let me hit the run button, right? So let me hit the run button. So now you can clearly see a sample test cases are getting passed. So I had to hit the submit button, man, not the run button. So yeah, now you can clearly see here all the test cases are getting passed, means the code works absolutely correct on this case. So whatever the code that we have written works for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.